On this video, we are going to make some examples on stationary points. Let's start with the first one. So f of x is given. It's equal to minus x to the power of 3 plus 3x squared minus 3x plus 5. So that is our f of x. And we have to find, first of all, the derivative of f of x. So that's point I. Okay. So the derivative of f of x is minus, so we have x to the power of 3, so we move the 3 to the front, so minus 3 times, and we lower the exponent by 1, so x to the power of 2, plus 3 times, we move the exponent to the front, so times 2, times x to the power of 2, we lower the exponent by 1, so it's going to be x to the power of 1, or just x. And then minus 3 times the derivative of x is just 1, so times 1. And the derivative of 5 is just 0, so plus 0, or you can just leave it like that. So the derivative will be equal to minus 3x to the power of 2 plus 6x minus 3. So then we have to draw the sign diagram or sign table of the derivative function. And we also have to find the position and nature of any stationary points. So we're going to do those two parts together. I and I. Okay. So to find the stationary point, we have to equate the derivative of the function to 0. So the derivative must be equal to 0 where we have the stationary point. So in other words, minus 3x to the power of 2 plus 6x minus 3 must be equal to 0. Or we can divide both sides by minus 3. In that case, the left hand side will become x squared minus 2x plus 1, and the right hand side is equal to 0. Because 0 divided by minus 3 is still 0. And this here is x minus 1 to the power of 2, and that must be equal to 0. Or x minus 1 must be equal to 0, or x must be equal to 1. So this is the x coordinate of the stationary point. To find the y coordinate of the stationary point, we fill that in the function. So we replace the x by 1, and that's how we find the x coordinate of the stationary point. So that becomes minus 1 to the power of 3 plus 3 times 1 to the power of 2 minus 3 times 1 plus 5. So that becomes minus 1 plus 3 minus 3 plus 5, and that is equal to 4. So we have a stationary point at the point with coordinate 1, 4. Okay. To find the nature of this stationary point, we have to draw the sign table. Okay. So the derivative of the function, we said it's equal to minus 3x squared plus 6x minus 3. So we can put the minus 3, we can take the minus 3 out, so then we get like x squared minus 2x plus 1 between brackets. Okay, and this here is equal to x minus 1 to the power of 2. And now we can make the sign table or the sign diagram. So here we have x and we have a stationary point when x is equal to 1. So we have a minus 3 here, and x minus 1 to the power of 2 here. Okay. So minus 3 is always negative. So negative, negative, negative. X minus 1 to the power of 2 is equal to 0 when x is equal to 1. So we write a 0 here. And when x is greater than 1, we have, like, for example, 5 minus 1, which is 4 to the power of 2, is positive. When x is lower than 1, so for example x is 0, then we have minus 1 to the power of 2 makes it positive. So this is positive. And then a negative number times a positive number is a negative number. A negative number times 0 is 0. A negative number times a positive number is a negative number. So that means that the function here it's decreasing, and here it's also decreasing. And we said that when the function is decreasing before the stationary point and decreasing after the stationary point, we have a stationary inflection. So here we have a stationary inflection at the point with coordinates 1, 4. For the last part of the question, we have to sketch the graph of f of x using technology, so we can do that on GeoGebra. Okay, let's go to GeoGebra. If you go to GeoGebra, then we will see that it looks like this. And here we can see the inflection point. Like the point has coordinates 1, 4. Okay, we just have to sketch this. We can see that the y-intercept is at 5 and the x-intercept is at 2.58, somewhere between 2 and 3. So we just have to sketch this. So when we sketch it, it will look like this. And here we have the inflection point. The x-coordinate is 1 and the y-coordinate is 4. And this is the point where the tangent, where the gradient of the tangent is equal to 0. Because the tangent is like this. And we can see very clearly that the gradient is equal to 0.